Hmm. Okay, so now, as we discussed a few minutes back, that the exercise which we were trying to do is we were trying to do brainstorming about how the social media is relevant in today's business, how it can make or break the business. So I gave you the 5 minutes before this particular discussion was started. I gave you the 5 minutes where you have collected your thoughts. I gave you 2 minutes to write your thoughts. Now, as a collective team, we have done the brainstorming and came up with a point where you will be telling us about that how the social media can make or break your business. So, sir.
Okay. Okay. So we have collected thoughts. I will explain one by one. So let me have a bullet points on this. We have spread different information, positive or negative, and then building the reputation of a company, the boost of competitiveness of the product, and then the social media reviews also, and give the edge over the competitors in the industry. Let me explain these things in a broader way. Social media is nothing but marketing, and company strategy on marketing will make or break their business, right? So with regards to social media, there's a lot of information in there. So whatever information that comes out based on the company's product or the company's business will have an impact making or breaking that company. Say for example, if one of the good product, one of the lowest startup cell phone companies, say for example, has a very good social media following and has a vast number of comments, posts, and saying that the product is very good, would you think that the product will be bought by many people? Yes, because that's marketing. Now, social media is the one is much more truthful than any of the reviews, right? So the review in social media is much more truthful than the salesman telling you about their product.
Or advertisement.
Or advertisement. Because advertisement is one-sided. It is always on the side of the one who's paying them. That's on their side. But social media is different. People will tell about a product if it is a negative or positive. It will be in social media. So it's all marketing, right? So when a salesman tells you that this car is having a very good review, but go to social media, you will see the actual review and the truthful review of the people over a product. So with social media, it is a marketing, and marketing is the main, it can make or break the business. Mm-hmm. If it's a bad marketing or a good marketing of a product.
So apart from that, do you also expect that let's say, if as a user, as you said, right, it's a review which is coming out from the real users.
Yes.
It's not just the marketing campaign.
Yes.
Marketing is one part of it, but even as a customer service,
yes.
I can say your product is not good.
Yeah.
Because if, let's say, if I call up a phone, let's say customer service, Singtel, and if they don't give me the right service, I have all the right to go in the social media and talk about it.
Yes.
So will it impact as well?
Yes, of course. That's why we talked about earlier that positive or negative, truth or not, will impact the business. Previously, in old times, a negative comment or a negative news, if it is negative and if it's not true, in mainstream media, it can be contained. Company can buy all the newspapers. Company can pay the mainstream media not to air the news. News blackout, as we call it. Now there is no more news blackout. Even what's happening in Syria is there in the social media. Even they want to contain any information, they cannot contain none. Because the social media is there, people are freely telling it, and nobody is regulating it because of the freedom of information. If there's a freedom of information, anything, company, people, can make or break by the social media.
Thank you very much, sir. Thank you. It was nicely summed up, and I think it was a good collaboration effort where all of you have put your thoughts together. So now we'll go a little bit on the more on the technical side, because till now we are trying to understand the basics of let's say big data, how does it help, what are the problems, and how does it solve the problems and all these things. Yeah. So now we'll go into the technical parts of it. So instead of what I'm doing in this particular exercises, instead of reading those numbers, I'm just trying to tell you this particular part, yeah, where we are saying that how this social media, how this different kind of technology will be helpful for you. So this big data use cases are almost everywhere. So you have the industrial use cases, you have healthcare use cases, you have genome sequencing, you have utilities like power transmission which is happening. So all those are use cases of big data, where you can utilize this data everywhere. So how do you handle this kind of data? Now comes that how do you handle this kind of data? The data which is getting streamed, the data which is so much of huge amount, right? So how do you handle this data? So in the beginning, when the computing has started, early scale, large scale computing, it was not storage bound. The data was very small because still people are trying to automate the stuff. From manual process, the focus in the beginning was how to generate the manual process, and from the manual process, how do I make it automated? Instead of doing the data entry manually, I'm doing that through computers. That was the initial focus. So at that point of time, when the computers were less and the storage was less, and there are a lot of things were less. So at that point of time, the data size was not too huge, and at the same time, the processing was also not huge. Like 15 years back when I bought my computer, it was Celeron processor, 32 MB RAM, and 4.3 GB hard disk. I remember my configuration still to today. 4.3 GB hard disk. Now 4.3 GB RAMs are there, right? In my computer, iPhones, right? 4 GB RAM, GB. So secondary storage versus primary storage. In the 10 years, it has improved in that particular manner. So imagine the way it has improved here. In the same way, the data has increased. Do you agree? All of you? So historically, computation in this computing part was more on the processor related, where the processing power was required more because the data size was small. Entry, people are doing entry only, right? And complicated computation was performed on that particular data volume, which was small. But now advances at that point of time, when the advancement was happening, let's make it computing advanced, let's make the computing advanced, let's make the computing advanced. People were too focused in improving the CPU capacity. Okay, so that's why you had the Pentium 1, Pentium 2, Pentium 3, Intel Core i2, Core 2 Duo, then Core i3, and then i7, and this and that, right? So all these performances have been increased, focus centered around increasing the performance of the CPU. Now the problem is this improvement of the CPU. You can handle, you can increase till certain level. Correct? There is ultimately all these are created from the semiconductors. And enhancing the semiconductor itself follows something called Moore's law. Moore's law means after a certain level you might not be able to enhance in that particular scale. Like Intel i7, you might have seen the same configuration 10 years back. i7 or i5 was there 10 years back. i8 I have not heard from so long, right? Have you heard from i8 for so long? i5, i7, i5, i7, we are hearing from the last 10 years. Why there is no further enhancement? They are trying to increase the clock speed. Clock speed, you know that? The CPU clock speed, the way it refreshes the data. But actual enhancement, kind of stagnant. Correct? So that's why you see, this is an example of Cray computers. Supercomputer, one of the supercomputer where a lot of CPUs are there. So Moore's law, this is the one which I was talking about. Moore's law, the number of transistors of a dense integrated circuit double every 2 years. That was the Moore's law. But then single core computing can't scale with the current computing need. When you have single core, that's why you create multiple cores, right? Dual core, triple core, core to Duo and all those things. So power consumptions also limit the speed increase. That how much? Because you try to make it more dense, it might blast also. That's why in the past 15 years back, all these computers we used to keep in air-con room, remember?
Mhm.
Nowadays you don't keep, it's okay, because now it has become more rugged, right? But in the past, oh, it's laptop or CPU or computer, even it's a black and white monitor, it has to be in air-con room. You sit outside in the office, a CEO will sit, let's say, maybe in non-air-con room, but computer has to be in air-con room. Remember those days? So now,
Maybe they don't have it.
you don't? You have not seen that?
Not,
Yeah,
maybe
so
they-
yeah, because the new generation. Yeah, so maybe it's okay. This we'll talk about that. Now I told you, right? Now I give you another assignment. Again, I'll be working on the assignment. The first half of it. Second half will be more on the practical. Yeah. So the first half. Now to solve this problem, how do you will solve this problem? When the capacity of the CPU is limited. Okay? Capacity of the CPU is now limited, right? Because you can increase it in certain level, but the data is growing much more bigger. Do you agree? Because now everybody has the iPhone, everybody has not iPhone, means smartphone for that matter. Everybody is taking photo, everybody is tweeting, everybody is putting say Facebook comment. 90% of the time people are there on the Facebook chatting. You see in the MRT or train or whatnot, people are, many times I see, in fact myself as well sometimes, maybe they will trip down from the escalators. They're just going, and sometimes, they might trip down as well. So these kind of, people are hooked into their phones. Whether you require or not, you will keep on checking your mail, any new mails. That was not the case in the 10 years back when we started. Because even if you have the smartphone, my first smartphone was O2 Mini 10 years back. You might not have heard about it. Yeah? So they had the stylus, Microsoft phone. But they didn't have 3G, it was just Wi-Fi. So only at home you can use. But now with the 3G enabling and all those things, everywhere you have the internet. You can use it left, right and center. And so easy. Instead of stylus sticking out and poking it, I come from very rural background. They say, why do you need a phone where you need to have a kind of stick to poke it? They had the valid point. They had the valid point which, let's say, which Steve Jobs understood, and they tried inventing it in a different way. Why do you need a stick? Somebody commented on my phone, why do you need a phone where you need a stick to handle it? So it was a good point. So now I give you an assignment. In the next 5 minutes, you have to figure out, just 5 minutes, that again, I'll create in 2 teams. One team will be you, let's say, because I don't have, actually I wanted 2 people, but yeah, right now you could be one team and I could be your team. And another could be this team, where we try to come up with the 2 different ideas, let's say, that how the distributed computing can be used. So maybe you pick it up that how do we, not distributed computing, how do we improve the performance of computers if the core cannot be improved? Okay? So maybe you give some points, he gives some point. It's already written, I'm not saying it's not written, but I want you to also contribute to some ideas. So come up and then we'll have discussion further, 5 minutes. If your CPU cannot increase, your processor system cannot increase and your data is increasing, how do you handle that situation? I gave the paper also. You can pass on the paper to him as well. Sorry. Yeah, password of the Wi-Fi. I get the blank paper, right? Yeah, so you can give them more blank papers. There are more blank papers as well there. Yeah, I just keep it here. Yeah, I'm counting the time. Okay. Can we sum it up? So, if they will say, let's say, X topic, yeah, you have to tell in Napoli. You have to, let's say, ask the questions on top of it. Let's say whatever they say, because they are the majority, right? Let them speak first. So you have to ask the counter question to understand that whether, whether all of them are right, yeah. So okay, sir, you can go ahead. First team. Yeah, you can come in. It's okay. And then he might ask a question from the different team.
Given the limitation of the Singapore desktop server, some ways which I read about is sharing of workload. That means among many servers.
Yeah. Can you speak a bit louder?
Is the sharing of workloads among many servers. I'm not sure if this technical term is it or data sharding. Yeah. And then second point is the non-shared architecture.
Okay.
Yeah, that means if one of these servers is down, it will not affect the operation, but it will so-called like share the workload or fail over to the other surviving servers.
That's very good.
Yeah.
Any questions?
That's a real application process.
So he came up with the point, let me just reiterate the point which he said. He came up with the point saying that if I cannot improve the performance of one server, let me do something. Instead of keeping, like say, one person doing the job, I'll keep many person doing the job. Instead of one server, I'll keep many servers. So in that sense, what he's saying, and the second point he's making is, when I have the multiple servers, any servers, I'm trying to do the processing from the many servers, any servers can fail at any point of time. So we should have the facility, we should have the capability that if one server fails, another server should take over that load. Correct? That's his point. So do you have any questions for him?
Yeah, that's valid.
That's valid, but do you have any doubt or questions which you want to ask?
No, I don't have, because I brought infrastructure. I will do the same thing.
And
With the current technology, not discussing. We're not discussing about anything about big data.
No, we are not
With the
talking
current
about-
technology, yes. In Oracle, you have real application clusters where you're also doing this.
Yeah, so right now, we will cut horizontally, we'll keep instead of vertically, right? Instead of vertically scaling, we will do horizontal scaling.
Yeah.
So this is called horizontal scaling, whether it's in Oracle, whether it's somewhere else.
Yes.
So this is very valid point, not much things to discuss, but again, because it's a technical thing, so you can relate to it, that any point of time, if something cannot grow, if let's say, just an example, it's just an example. If there is if at one particular truck can carry 1 ton of truckload, right? And if you had to carry 100 ton of truckload, right? In the current model, when they're trying to increase the processing power of one CPU, what they're doing? What are they effectively doing? They're trying to create a truck which can carry 100 ton. You're getting the point?
Yes.
Which is kind of, yeah, to a certain level, maybe not 1 ton truck, they should be able to create a truck which can be carrying, let's say, 3 ton of truck. But they might not be able to create a truck which can carry 100 ton. You know what I mean? Even if they are able to create a 100 ton of truck, there are complications of it. Let's say, imagine they created the 100 ton of truck. First of all, it will create a big hole in your pocket because it's a specialized system. If it is a specialized system, that means you have to pay a lot of money for the vendor. Regardless of vendors, Teradata, this, that, all those companies which comes with those kind of processing, Greenplum, Netezza, all this cost a lot. All this cost a lot, and as soon as the data a little bit increases, the cost also increases in the proportionate way. That's first part of it. Increases the hole in the pocket. I'm trying to sum up what he came up with that. Second point is, even if you get 100 ton of truck, 100 ton of truck which can carry the truckload of 100 ton, you might not get a road for it. You might not get a road, path which can carry that truck. Because it's so big, it might not fit into the existing pathway. Or even if you want to make it vertically up, let's say, then it might touch some bridges. If you want to make it horizontally, let's say horizontally longer, then it might not be able to turn into the trunks. Why I'm telling that? It's just related with the new topics. So with that, I come introduce you to distributed systems. So what is distributed system? In distributed system, what happens is instead of using one particular system, one particular server, you use lot of servers, lot of systems to process the same thing. So you are not trying to create a truck of 100 ton, rather you are utilizing 100 trucks, which is commodity. Because right now you are hiring 100 trucks, it is not a specialized thing for you, right? If it is not specialized, you will not be paying premium for it. Otherwise you have to pay premium for it, correct? For hardware plus software. Clear? Premium, extra money. Yeah? So this distributed system is not a new concept. It was there since ab initio, from long time. Okay? Now I am coming back again. It was there from a long time. But then distributed systems, in the previous world, there were a lot of problems. So what are the problems? What are the challenges? So the programming of the distributed system was complex. So complex, when I say, that means when you have so many different systems, let's say in just this computer, these many computers, just whatever the computer is there in this room, forget about big infrastructure. If you have to process the data, same data, across the system, so you have to do the network programming, socket programming, data synchronization. Make sure that all of them processes in the same synchronized way, dependency, so many different things. So it was too complicated. So that's why it was not used in the mass scale, until unless you have real purpose. So distributed computing is not new concept, it's an old concept. It's not new concept. We have been learning about it from 15 years, 20 years back. Correct? So it was there long back. But then programming in it required a lot of specialized technical skills. It's just like when when you do the assembly language, right? Assembly language programming, you have to shift the bits 0, 1, 0, 1 here and there. That's much more complicated than writing into your SQL, correct? In the same way, it was like writing 0101 programming. Assembly language. Assembly language, anyone? Where you do the programming and shifting the registers. If you are technical background, if you are coming from the hardcore IT background, then you would have done the assembly language programming. In assembly language programming, we try to play around with the processor without any programming language. We try to play with 101, which is very hard actually. So in the similar way, it was very hard in the past. Okay? So synchronizing data exchanges, managing a finite bandwidth of the exchanging the data, controlling computation timing was very complicated. And then another problem was as soon as, because distributed system, there are so many servers, right? Any servers can fail any point of time. No, never know. Systems tend to fail, right? Sometimes memory might not work, sometimes CPU might not work. As he said rightly, your system should be capable of handling this kind of failures. So it has to be fault tolerant. The word for this is fault tolerant. Clear? Yes? Go? So, in the past when the distributed system was there, I just want to make the story behind, then come to the Hadoop, and then come to the next one. So in the past when the distributed system was there, the data used to be stored in the different system and computing used to happen in the different system. Only when computing is required, then you used to move the data from data to computer. So that's the way it was designed in the past. It was good for relatively small amount of data. But then modern new systems deal with a far larger amount of data. So when we say the data has increased, it's a big data, it's not new, okay? All the while, the problem was there, okay? When let's say relatively, always things are relative, right? Relative means when the CPU is Pentium 1, maybe the data of 1 terabyte itself is a big data, correct? When the CPU is, let's say, when the RAM is just 32 MB, maybe the data itself is 1 GB is too big. So all terms are relative, right? So why we are talking about big data now? Distributed computing understood, right? So now big data we are talking about now, because initially, as I said, 20 years back, when you used to, maybe you might not be able to relate to it, but still I'm giving an example. In the past, when we used to, again it's an example, it's like case study. Case study, yeah? It's a case study. When you go into the bank in the past, if you have to withdraw the money, how much time it would have taken? And what is the process? Okay,
Queue.
yes, queue, and queue, how much time it will take? It will take at least half day, as I say, half day. It's a half day exercise. You cannot imagine, as a new guys, you might not imagine that it used to take half day just to withdraw the money. So there was no ATM, nothing, and when you used to withdraw the money, it used to take half day. So people don't used to go very often. They used to go maybe 10 days one time or 20 days one time, withdraw the money, keep it for the whole month kind of thing. But it's not flexible. Because of the flexibility of ATMs, number of transactions has also increased, correct? Because now you are flexible, you can withdraw $20, $30, $50, whenever I require, I will withdraw.
Or maybe one person in front, then there can be many staff who are taking out the voting slip.
Okay. Okay, so no problem. Maybe you can also add into something, sir.
Okay, the process is after all the voting has been done, they will open the ballot. There is somebody in the front who is having a table of the names of the candidates, all of the candidates from the topmost candidate down to the lower level candidate. And then there will be one who will be reading the votes of each of the ballot. And then at the back, there are people who are looking into the ballot if the guy reading the ballot, the votes, is reading it correctly. And then there's another guy who's holding another box wherein after reading you will put it there. So you will read one by one. Like one candidate, say for example for president, who's ever voted by in this ballot will be read aloud, and then the guy in front who's taking care of the table will mark it as, you know, one for each candidate.
Very nice. Very nicely summed up. So very nicely summed up. So your MapReduce process, with that, I want to introduce you to the MapReduce process. So MapReduce process is nothing but a ballot counting process. Okay, like we put in the analogy and how the practical works. So for example, what happens in the ballot boxes? Once the ballot boxes are there, so let's say there are thousands of ballot boxes, right? If thousands of ballot boxes, if one person starts counting, it takes a lot of time. Correct? If there are so many candidates, let's say there are 15 candidates. For 15 candidates, if I have to count, one person has to count all the 100 ballot boxes, it will take ages. Correct? So what they do, they create multiple teams who can count one, which I said, right? One, for each this candidate, one, whatever, next one, no. So for every candidate, as soon as the value comes in, they write one. Okay? So there are 5, let's say imagine 3 candidates. Candidate 1, first vote came, candidate 3, candidate 3, 1. Candidate 2, candidate 2, 1. Candidate 1, candidate 1, 1. So they keep on writing 1. Okay? But then there is not only one team which does it. There are multiple teams. So what they do, they divide the ballot boxes into multiple different teams. So the writing process of 1 is called map. Then there is another team which is sitting up, which will get the values from all the different teams who is doing the mapping. 1. Okay? They will get the value and they will sum it up for every candidate. So there is a different team which takes the value from each candidate, each team, or every candidate. Give me the candidate 1, how much the count, give me candidate 1, how much the count, give me candidate 1, how much the count, give me candidate 1, how much the count. From let's say 14, right? I got from all the 14, I sum it up, I get the final value. Correct? This process of summing up is called reduce. Okay? So in this way, they expedite the process, so that the ballot can be counted very fast. Not just one person is counting it, because if one person will count, then it will take a lot of time. They keep a lot of teams to do that. The local team which is doing counting 1 is called map. In real life world, in our programming world, it's called map. Okay? On the other hand, when the person who is summing up is called reduce. Okay? So now I'm going into the more details. So in the beginning itself, when you store the data in HDFS, at that point of time you divide it, saying, this divide here, the store in the different servers, right? That means while you are storing the data itself, at that point of time you are assigning the different servers, different teams. And after that, when you are processing, then you are saying those servers start doing processing. Only the intermediate results comes out. Intermediate results has to travel from the mapper to reducer. You got me? Intermediate result means the person, because he will have same candidate 1, 20% of the vote. He might have the 30%, he might have the 70%, he might have the whatever the numbers. Yeah? In total it has to be 100%. So he will get from all candidate, for all the candidate, one by one for all the candidate, he will get from all the different teams and sum it up to get the final result. You got it? It's a divide and conquer. Divide and conquer. Divide and conquer is like MapReduce. Clear? MapReduce analogy is clear. What is MapReduce? How does it work? Analogy? Yes, no? So each node, that's what it's saying, each node can then perform computation of the data it stores without moving the data for initial processing. Clear? So now let's move on. High level view, what is HDFS? More Hadoop concept we already discussed about. So Hadoop is a way of doing the distributed programming. Like we discussed the distributed programming, right? Remember we discussed about the way of distributed programming? So distributed programming, in distributed programming, you are trying to attach so many servers, you are trying to combine so many servers to do the processing. Correct? So with that processing, because it was complex. To make it simplified, somebody has created a higher level. Like, instead of writing assembly, you are writing C code. When you have to write C code, C++ code is much more easier than the playing with the 0, 1, correct?
Yeah.
Same way, they have created this Hadoop, which can do those data synchronization, those, network programming, all those things without, you don't have to worry about it. This is a high level framework which will take care of the data processing and all those things. So distributed programming, Hadoop is a way of doing the distributed programming without knowing the distributed programming. So complexity it is hiding from it. It's abstraction layer. Okay? So that's why Hadoop is becoming popular, because it has made distributed processing a common man thing. Okay? Instead of a specific network programming skill guy thing. Huh? So application programs are written in high level programming language, no network programming or temporal dependency is required. Use search engine, right? Left, right and center. Correct? Use so heavily, right? But how does search engine works in the background? That's the question. So search engine, I'll give you 1 minute to think about it, but what this search engine is all about, how they might be working in the background. Okay? Then come back to me once again. Just let's not 1 minute will be too short. 2 minutes. Combine your thought. Explain me. Yeah? Learn from each other. So how the Google might be working?
Index. Where index. Keywords sometimes. And then when it is indexed, someone search. That's why there is top search. Right?
Oh,
Because those were indexed by Google.
even when you're typing,
Ah.
it will come out.
Say for example, there is this website, and then there's a lot of words inside, title, tags, those keywords. I think those are being indexed by the Google.
We categorize the certain words, how it work on a topic.
And the way I say, for example, this book, there's a lot of content. If this is in the internet. There's a certain website, like Hadoop. Hadoop is the main tag, what the main keyword. Right? And then there's a lot of Hadoop pages. And this website has been mentioned to some other website. It will be indexed by Google, and then it will be on the top search result.
The initial one will not also called search.
Yes, subsequent search. Subsequent search, and I think if it is being selected, you have search, you don't select all the searches, right?
Yeah.
So once Google has given the result, whichever is being clicked, I think they are also giving consideration. Previously it's just index, but nowadays it's different. They are doing many analytics on the websites. Previously, if you have search, say for example, how to raise a pump, say for example, you type how to raise a pump. The very first result that will come out is a website which having how to raise a puppy.com. Now it is not like that. Because how to raise a puppy.com may not be indexed by Google. But some other which is having tags as raise, puppy, how to, dog, like that will come out first. So in the previous times, Google is indexing all of it, whatever they can see, whatever is the result has been, whatever they have indexed. Now it's different. There is a search engine optimization now for every website. That you have to know how it works, put it on your website so that the Google can index it as per your liking.
Optimization.
SEO, they call it SEO now, search engine optimization. So what Google will do is they will index your website as per SEO setup, meaning how you set up the search engine optimization in your website. So you see, there is a website which is exactly your search key, but it's not coming out at first because it was not indexed. I think it's indexed by Google.
Okay, so now conclusion. Time for conclusion. So maybe right now, sir, I'll give our lady the chance to conclude. Yeah.
Same thing.
Yeah. Maybe you can just sit and then conclude. It's okay. You have to stand up.
Actually, I'm quite curious on how once we type the keywords in the Google, the engine give us the record
Suggestions.
which we have stored in somewhere, or on the fact we search all the website. So because the record give us very fast, normally in 1 second. So this is what I don't know.
But he's explained few points, right? We discussed few points. Did you learn something from him? What are the things which you learned? No, he gave few pointers.
Yeah,
It might be right, it might not be right. We'll correct it. What I'm saying is, what he gave you some points. He also spoke about some point. So what did you think about from his point? Do you have any doubt about his points? Or did you agree with the point? Or let's say, you have some other thought about it. So what he said?
I agree with the index part.
Yeah.
Yes. You must put some index to make you put things fast and efficient. Yeah. That's what I'm not sure.
Okay, so how about you, sir?
So basically on the part wherein they are doing it in 2000s and the Google doing it in 2000 is, I think,
Let's not be specific into the advanced part of it. Normal. It's how the
I
Google
think
works.
it's indexed because in the search engine we have this kind of search engine optimization now wherein you put certain keywords and tags along your website so that Google can see it, and the only way they can have a fast search is that they have to index those keywords pertaining to the website wherein those keywords are properly arranged, or in a search engine optimization theory way, I don't know, but it is indexed actually.
Mm-hmm. Okay, very nice. I think that's a good. That's a good way of concluding the things. It just I'll just let's say add some few pointers to it. Okay. Okay, so what is the pointer here? So the core idea, the way that Google does and the way the Hadoop comes in is from the same thing. They come from the Google idea. So the idea is simple. What is that idea? The whole world website get the dump of the content. Because if one word is found more into one website, that means that word is more relevant. And if you have more links to it, that means it's more relevant. Correct? So what they do? They get the data from all over the world website. They dump it. Then based on that, they process the data. The indexing which you call, they call it a page rank. Ranking of the page. Which page should appear top, which page is more relevant. So they do indexing, but the index particular word for that is page rank. Clear? They create the page rank based on the keyword, based on the link referred from here and there. So how they do? They bring the data from all the websites. Imagine so much of websites, right? So many websites are there. How do they bring the data? It might be in zettabyte, not petabyte, right? Because the whole website, many of the website contain the databases, many of the things. How they bring the data and how they process the data. That's where Hadoop, Google says this is the way we store the data. which they called as a Google file system. So Google file system, the original idea was one system anyway will not be able to process the whole world of website. Can we process from one system the whole world of websites? Cannot. So let's bring the data, store the data. While we are storing the data itself, cut into pieces. After cutting into pieces, do the processing. So cutting into pieces is called Google file system. So based on that Google file system in 2003, they have written a paper saying, this is the way we do our file system. This is the way I store the data. And 2004, they said this is the way we process the data after storage. First one is storage, right? How do I store? Second one, how do I process this data which is stored? You got it? Processes plus storage. So Google file system, later point of time, based on this, inspired by this, another file system was called, which was called Hadoop distributed file system. Hadoop, remember, forget it for now. Distributed file system means file system is not in only one server. Generally your OS file system, how is it there? It's there in one server, right? Here I'm talking about so many different systems. So that means the file system is distributed. So based on GFS, HDFS. HDFS stands for Hadoop. Hadoop is just a name. Just a name. Nothing, no meaning out of it. Hadoop distributed file system. Okay? And then how to process this data is called MapReduce. So huge amount of data, so many of servers, how do I process? MapReduce. We will talk about MapReduce. MapReduce, so the core idea was to distribute the data as it is initially stored. Each node can then perform the computation on the data it stores without moving the data in the initial processing. Okay, so that's the core idea. So now I'll go back to the next part. Next part is the MapReduce. Okay, so you know now, right, that why do we require to store the data into many servers? Because one server anyway will not be able to. It's like if I want to process all the data by one server, that means I have to create 100 ton of truck. Remember, a few minutes back we took that analogy. 100 ton of truck is so much costly. Google will not do that, right? So they said, let's do something else, which is distributed processing. Distributed storage is fine. Now for distributed processing, there's the MapReduce, right? So MapReduce, before we go to the MapReduce and talk about technical thing, how it works, I want you guys to conclude, let's say, election, right? You have you voted ever? Voted? Voting? You are from China? That's why I might not have voted. You have voted, right? You are Singaporean? That's why you have voted. Right now, so the point here right now I'm trying to understand that you guys conclude that how, if let's say when the processing happens, you have to explain me as a student that how this balloting works, how the counting works, okay? And where is the optimization happens, where is the best way to do counting, the complete process. So when I go do the voting, after voting what happens? You did the voting, ballots are there in the ballot boxes. Your voting papers are there that which candidate I select into the boxes. After that what happens? That process you guys have to discuss and explain to me and explain to other people as well. You got it, right?
Yeah.
Simple.
Nobody goes to the after.
Simple.
Okay.
After, sir, the vote is already there in boxes. Yeah?
Voting, wait. Did you stay after voting? No, I stayed once after voting and the counting. It is like this. It happened in school, and one time I was working as a watcher. So how they count it manually, they have this president, vice president, and then vice president candidate, and then the names of the candidates, vice president, the names of the candidates, and then senators, ministers here, the name of the candidates, and then one by one, the ballot, they will open it, take the one of the ballot, and then somebody will read president, okay, say for example, Who's the president?
Singapore. Tony Tan.
Oh, Tony Tan. Tony Tan, one. Then another guy, say for example, vice president, next is senators. They will read and then they will put the count. And then they will take the next ballot and then another candidate, just like that. So they're processing like that, manually. So, and then after all the ballot has been counted, they will count the vote of Tony Tan, total it, vice president, all the candidates, total, and then they will sort it out, and then they will put it onto the one paper, with the count, sign it, close it, seal it, put it back on the ballot, send it to the Commission on Election or Ministry of Election, and then from there I don't know what's happening inside.
So, you guys have already discussed, right? Now, you have a fair enough idea. He has explained. Can you come to the stage and tell us how this, voting is happening?
It's a manual process.
Yeah.
Every vote counts, so it has to be precise. Yeah.
And then, how the process works?
So for every voting box, there will be staff doing the counting one by one.
Mhm.
So you will have to count the number of votes per candidate, how much they receive, and then they'll write it, they'll total it up and sign it up.
So, one question here. So, do you mean that one person is counting all the votes, all the ballot boxes? Or is there a team of it?
Yeah, it could be a team of it. Yes.
I'm just asking, it's a question, it's coming to my mind. Yeah? The counting which is happening 1-1-1-1, if one is required, no one should communicate as little as possible. This is another part, you see? That means the intermediate result only should move. The initial data should not move. So no one should communicate as little as possible. They don't try to communicate, like say, during the previous distributed programming, as I said, data used to be separate, compute used to be separate. During data processing, the data used to move to compute servers, right? No more. Nodes should communicate with each other as less as possible because the data itself is split, small chunks as kept into many servers. And data is spread among the machine in advance, perform computation that is already stored as often as possible. You see? Data is spread among the machines in advance. When it is in advance, when you store the data into HDFS. HDFS is a way of storing the data, right? Remember? We spoke about HDFS is a way of storing the data onto many servers. Okay, so when the data is loaded onto the system, it is divided into blocks. Blocks or chunks you can say, yeah? By default the name is block. It says 64 MB, but nowadays it has become, by default it has become 128 MB. 128 MB is a big one, huh? It's a big size. It's not even like your local file system. Local file system, it can be KB or let's say maximum, let's say,
8 KB.
8 KB what not,
8
yeah?
KB blocks.
8 KB blocks, right? Here it is 128 MB blocks by default nowadays. 64 MB blocks are no more the standard. Then based on this data which is stored on the many servers, while you store the data, right, you can do the processes. And the processing is divided into two parts. Map task, where the data which are done on the small portion data where the data is stored. So what is map? Small portion data, clear? Any questions on that? Map is just like taking ballot boxes, started counting 1, 1, 1, 1, 1, 1, 1. Clear? And reduce is getting the result out of all the different teams and summing up. Reduce the task which combine data, intermediate data to produce the final output. Concept was clear? You'll see the hands-on soon. Don't worry about it. A master programs allocate the work to individual nodes. So master guy, there is this whole architecture is master and slave. Okay? So master slave architecture means there will be a guy who will be telling that where the data should go and store. And there should be a guy who should be telling that this is the places you should go and process. So this is master slave architecture. Okay? Then fault tolerance. Remember we discussed about any distributed computing should be able to support the fault tolerance. Correct? So what does it mean, fault tolerance? What does it mean, fault tolerance? Fault tolerance means if server goes down, or system goes down, or CPU goes down, it still should be able to process the data. So in this case, failures are detected by the master program. So let's say if your one team become dysfunctional, right? If one team becomes dysfunctional, or he might leave because of XYZ reason, because maybe he's supporting the X candidate, you assign the work to other team. You always have a backup team. We'll see how. Okay? So failures are detected by the master. So master, there is a chief presiding officer in the the election booth, right? The head guy who allocates the work. So this is the head guy. So if one team for some reason he says walk out, that I don't want to do counting, somebody else will bring it. Okay? Failures are detected by the master program, which reassigns the task to the different node. That means if this server goes down, still I can process with other. If this goes down, still I can process with other. Okay? So that's about it. Restarting a task does not affect the nodes working on other portion of data, because the data is stored in small chunks, right? Some of them are here, some of them are here, some of them are there, some of them are there, some of them are there. If just this is restarting, if this is just shut down, right? It should not affect on the processing which is being done by this guy.
How to transfer the data in this?
Sorry?
How to transfer the data in the server
Which is having this one, right? This server goes down, right? So by default what it does, it creates 3 copies. By default, it's smart. In the beginning itself, when you store the data itself, it says, okay, let's not just keep 1 copy, maybe this, if this can fail, that can fail, anything can fail. Keep 3 copies. If this guy goes down, you still have 2 more copies. And any point of time, master will detect, okay, this guy goes down, create 1 more copy, so that it's always 3 copies.
in the moment when the one down, so create another.
Another.
So it's impossible the 3 servers that.
Correct, that's what I'm saying. So that's the fundamental behind, but there are a lot of configuration behind. Many times you say that, because if let's say this fails, right? If this fails and automatically you start doing the copying right now, then what will happen? That your network might choke because you are trying to transfer so much of data, right? You know what I mean, right? You're trying to create 1 more copy of, for example, 1 terabyte, network might choke. You're trying to spread the data, right? So in that case, you can fix the bandwidth, saying only this much bandwidth should be used for copying, for creating the extra copy. Don't utilize my whole processing powers. Don't utilize my whole network bandwidth, but only this much. You can configure all those. You know what I mean? So, if a fail node is start, it is added back to the system and assigned new tasks. So let's say if for some reason it failed, right? It created more copies. If it comes back, again it is assigned. No grudges that you didn't do work and we will not give you work again. Come back, okay, it's fine. But then in some cases there might be more copy. Because it came back, I already copied the 3 level of data, 3 copy data, then now it's 4 copy, right? Now it's 4th copy is right? Know what I mean? In that case, again, to balance, if it is more replication, it's called replication factor. Copying is called replication factor. If it is more replication, then minimizing, making it 3, and if it is less, then making it 3. Both of them are done by the framework itself. Okay? If it is more also, then it will reduce. Just delete that. If a failure node is start, the master can redundantly execute the same task to avoid slow running nodes. So in some cases, some guys are good, some guys are bad. Some guys are good in coding, some guys are bad in coding, right? So what it will do in some cases, it will also make sure that if this fails, if always you are slow, you are not doing the work properly, and I have the same capability guy, let's say him, who can do the same thing, I'll give both of them the same task. See who comes first. This is called speculative execution. Speculative execution. So you talked about data, right? You talked about data. If the data goes down, how do I find out on the data? How about during the processing fails? Correct? And you don't respond to the master. In that case, I'll start, because I have always 3 copies of data, right? I always have 2 more options. So I will start with either of the two options for the processing. What if this comes back and start giving me the result? Then I'll see who comes first. Whoever comes first, if he comes first, I'll say thank you very much, I triggered you, but then I know that I gave you the duplicate work because he was not responding, but now he came back, he gave me the result, please thank you very much, kill the job. Otherwise, take the result from here or here. So, for me, I want to be fault tolerant, I want to make sure regardless of what goes, I get my result. Whether he does it or he does it or he does it, I don't mind. I have three options always. Got it? So, fault tolerance. So, this way of triggering other for execution, if this fails, it's called a speculative execution. I am speculating, this node has gone wrong, this server has gone bad. Got it? Yeah. So Hadoop distributed file system, again these are the numbers, I don't want to go into the numbers, data volume numbers and all those things. You see, when you have to read the data, this is the one which I was talking about a few minutes back. Can you see here?